So let's talk about something like this where it says find approximate solutions. Now what this means is that these solutions are going to be square root solutions. Not every quadratic will cross the x-axis at a whole number or at a fraction number. Sometimes they'll be called irrational, and irrational means that it comes from a square root value. Now the process remains the same. We're going to use the quadratic formula, but our answer won't end at something nice and neat. Another thing that's important to know about this is that if we get an irrational solution, or one that has a square root, that means that factoring will not work. So that means on this particular problem, there is no way to factor it. If you tried to spend time finding ways that you could get, starting off 2x and x and trying to find the factors of 7, that would all sort out to find you that 4, you wouldn't be able to do it. You would not be able to factor. Quadratic formula is going to be the only method we can use. We actually can't even use completing the square on this one because our a value has to be 1. Our a value is 2. So quadratic formula is the only option that we have here for us to solve this quadratic equation. So as always, start off with your template. And on this here, we're going to be putting in our a value, our b value, and our c value. So there's the setup. And then from that, let's just start to simplify it. So up front, we have a -4. Underneath the square root, I have 16. And then I have a -4 times 2 to get a -8. -8 times the -7. It's a positive 56 all over 4. So we have -4 plus or minus the square root of 16 plus 56. That gives us 72 all over 4. Now here's what we can't do. You are not allowed to cancel out these 4's because there's addition or subtraction there. We won't go all the way through the simplification process on this. That gets saved for Algebra 2. But we will split off into the positive and negative case. So we have -4 plus square root of 72 all over 4. And we have -4 minus square root of 72 all over 4. And so what that means is we'll get the two answers, but we'd have to type them in on our calculators to find the decimals. Now, this is more so the answer that you would see on most answer keys. They'll leave it grouped up and call it like this. That's what we'd call it for now. This problem can actually be more simplified once we learn some things in Algebra 2. But this is where we're at right now. Now to find this answer, we would need these two answers, we need to type them in on our calculator. And what you need to be careful about on your calculator is make sure, just like we talked about previously, you need to make sure that your numerator is done first. So you need to tell your calculator with parentheses to do -4 plus the square root of 72 first, and then divide it by 4. And when you do that, what you'll get is x is about 1.12. And if you do that same thing on your calculator, except this time you do -4 subtract 72 and divide by 4, you'll get about -3.12. So it still tells me where I cross over the x-axis. It's just not a whole number or a fraction. That's what the quadratic formula is for, is to help us solve scenarios like this to where these values would be impossible to find by factoring or completing the square, from what we've learned at least. We need the quadratic formula to find it. It would look like this, but the decimal version, which would be easier to graph, is those answers right there. So I'll do one more with us here, and then I'll leave one for you. let's take a look at this one. We need to use our quadratic formula. So hopefully after you've written this out a few times, you're starting to get familiar with this template. And we'll put in our A value of 7, our B value of -2, and our C value of -8. And let's go through and simplify this. So we'll get a +2 out front. Underneath the square root, we'll get a 4. And then here we get a -28 times another -8, so it'll turn positive, plus a 224, all over 14. So what we're going to be looking at now is 2 plus or minus square root of 228 all over 14. Now, if you try to square root 228, you don't get a perfect square, which means that this is essentially how we'd see the answer on the ACT or in textbook answer keys. To find the two decimal versions, though, we need to do both the positive case and the negative case. And so when you type in your numerator into parentheses on your calculator and type it in, the two answers that you should get on this are that x is about 1.22, and then when we do the negative one, we get a -0.94 after you round. Now, what we can have you do is attempt this one using your quadratic formula. So pause the video, write out your template, right? So here's the template. And then go through and try to find your answers. Now, it could be decimal answers like we've been seeing, could be whole number or fraction answers. We'll have to see by using the quadratic formula. So pause the video and give it a try here for yourself. And when you push play again, you will have my work shown out to find the correct answer. So when you solve this one out correctly, you should get a value of 2/3 and another answer of 1. And you can re-pause here and take a look at the steps to see where maybe you went right or wrong, but make sure that you're able to reach the correct answers of 2/3 and 1. Now, what these answers tell us, one more time, by them being fractions and whole numbers, is that we could have factored this. But this one looks a little intimidating to factor, especially because of that negative sign out front. So the quadratic formula can be used to find us the answers as well. So here's what we've got. There's something called the discriminant. And what the discriminant is going to tell us is how many solutions to expect. So I've got 3 quadratics here that we're able to see. This one has 2 solutions. This one has 1 solution. And this one has no solutions. What we're going to do is use the quadratic formula on all 3 of these to see what makes it happen to where we can get something other than 2 solutions. All the ones we've done up to this point have been 2 solutions. What would happen in the quadratic formula to get 1 solution? Or what would happen to get no solutions? That's what we're going to discover, and it's something called the discriminant. So what I want us to do is I want you to pause the video and get all 3 of these quadratic formulas set up. And then we'll check in, and then we'll pause and move to the next step. But right now, you're just going to get all 3 of these quadratic formulas set up by using the template that we've been working with. So go ahead and pause the video and do that now. Alright, so here are the setups on all 3. Now let's go ahead and do the next phase. So we'll pause and do the next phase of shrinking it down. So I'll model this first one here for us. So I'd have a +6, plus or minus, and then I'm going to calculate what's going on underneath the square root. So here I have a 36 minus 12, which will give me a 24 underneath my square root. Try that for the next two and see what happens. Figure out what's underneath that square root for the next two. Calculate it and then return to the video. Go ahead and pause it. Here's what you'll get. On the middle one, you'll get a 0 underneath the square root. And then on the final one, you will get a negative number underneath the square root. And let's talk about how this all plays back into the pictures of the graphs. This one will have two solutions because I could split it off into both the positive case and the negative case. This one's only going to have one solution because the square root of 0 is 0, but there is no such thing as 6 plus or minus 0. So this one only has one solution. When you try to solve this one, we can't take the square root of a negative number. That gives us an error. And that's what makes this one have no real solution. So, what the discriminant is, the discriminant is something that's underneath the square root. The discriminant is this part right here. It's the b squared minus 4ac. It tells us how many solutions to expect. So if your discriminant is greater than 0, which means it's positive, you're going to have two solutions because you'll be able to split off into both the positive and the negative case. If your discriminant is equal to 0, though, you will have one solution because there's nothing to split off with the plus or minus. It's just whatever your two numbers divided by are to get one solution. And if your discriminant is less than 0, which tells you that you're negative, that's when you get an error and you have no real solutions. The discriminant can help you find out how many solutions something has without actually having to find them all or making a picture. Now that we have graphing technology, using discriminants isn't as important as it used to be, because we can just type in on our calculators and see what's the picture look like. But they didn't always used to have that, and they'd use the discriminant to figure out how many solutions they're expecting before they went in and tried to solve it. So, in order to use the discriminant, it's a part of the quadratic formula, so you do need to be equal to 0. So this one, for example, would need to have 1 subtracted from both sides. And the discriminant is only the b squared minus 4ac part. It doesn't tell us what the answers are, but it tells us what type of answers that we should be expecting. So we have our b value is negative 5, our c is negative 1, and our a is 3. So when we do this here, we get a 25. So negative 4 times 3 is a negative 12, times a negative 1 is a positive 12. We get a discriminant of 37. 37 is greater than 0, so that tells us that this graph, if we were to make it, is going to have two solutions. It would look something like this, where it has two crossover spots. Two solutions is there in blue. One solution here in green, and then no solutions where no matter where you go on your graph, you'll never hit the x-axis. And that's the quadratic formula.